Hello everyone. So in our previous video, we actually saw the problem of merge intervals. So in this video, we will actually see one more problem, insert interval. So friends, before we start, in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. So in this problem, we are given with a list of non-overlapping intervals which are sorted by their start time. We are also given with an interval which we need to insert into the list at a valid position in such a way that if that interval overlaps with any of the intervals which are given in the list, then we have to merge all those intervals and return back a list of mutually exclusive intervals, which means we need to return back a list of intervals which are different and non-overlapping. So let's see an example. Let's say we are given with this list of intervals 1, 3, 5, 7, 8, 10. Now they are non-overlapping and sorted by their start time. And let's say we are given with this new interval 4, 9. Our task is to insert this 4, 9 into this list in such a way that if this new interval overlaps with any of the interval given in this list, we have to merge it with new interval and return back a list of mutually exclusive intervals. So the output is 1, 3 and 4, 10. Now how this output came, let's see via diagram. So this is our time axis, and if we plot all these intervals on this time axis, it would look something like this: 1, 3, 5, 7, 8, 10. We have to insert 4, 9. So it will go from 4 to 9. So here you can see this 4, 9 doesn't overlap with 1, 3. So 1, 3 doesn't get affected by insertion of 4, 9 because they are not overlapping. So 1, 3 will be part of our answer because it's mutually exclusive. So this is the first part. Now here you can see when we will insert 4, 9, it will affect 5, 7 and also 8, 10. So as 4, 9 is completely overlapping 5, 7, if we put 5, 7 on top of 4, 9, that means merging of these two intervals will not get affected because 4, 9 is already overlapping completely 5, 7. But in this case, 4, 9 is ending at 9 and 8, 10 is ending at 10. So if we put 8, 10 on top of 4, 9, the region will get expanded till 10, and as 4 is less than 8, so start will remain the same but end will change because 4, 9 is overlapping with 8, 10, and when we merge these two intervals, we take the end time of both the intervals and we see which is the maximum. So here 10 is the maximum. So the merge interval will be something like this. It would be 4, 10. So the next output is 4, 10. Now let's move ahead and see some of the concepts behind this insertion and merging. Let's say we are given with these two intervals. We need to insert A. So A and B are non-overlapping. So it means we can simply insert A without touching B. So we simply insert A. Now let's say A and B are overlapping. So when we will merge these two intervals, their area will be from here to here. So this is the start of A and this is the end of B. So if we take this interval as C, then we have to keep a formula as C. Start time will become the minimum of A dot start and B dot start, and the end time will become the max of A dot end and B dot end. So this condition comes into picture if they are overlapping. So here you can see, let's say if we give it a value as 1, 4, 3, 6. So we know that when we will merge these two intervals, the minimum of 3 and 1, so C will become 1, and maximum of 4 and 6 will be 6. We know that the area of this merging will be 1, 6 because we have to accommodate both the intervals. So this formula comes handy. Minimum of A dot start and B dot start. A dot start is 1, B dot start is 3. So minimum is 1, and C's end will become max of A dot end and B dot end. A dot end is 4, B dot end is 6. So C's end will become 6. So this interval will expand from 1 to 6. So C becomes A dot start, which is this, and B dot end, which is this. Similarly, here A completely overlaps B. So if we apply this formula, the C will become A dot start because A dot start is coming before B dot start, and C dot end will become A dot end because it is coming after B dot end. We have to take the max value. And if this is the scenario, then by applying this formula, C start will become B start and C's end will become A's end. So this would be the area of the C interval. And if B completely overlaps A, and if we want to insert A, so by applying this formula, C start will become B start and C end will become B's end. So this is how we actually insert and merge the intervals together. Now let's see via an example. If we have these 4 intervals which are non-overlapping, sorted by their start time, and we have to insert a new interval 4, 9. So if we plot all these intervals on the time axis, it would look something like this: 1, 3, 5, 7, 8, 10, 11, 12. Our task is to insert 4, 9. So here, as we want to insert this new interval from 4 to 9, there will be 3 regions around this 4, 9 which will get affected when we will insert this new interval. So one region is just before 4, which is this. Another region is this, between 4 to 9, and the third region is just after 9. So here we are taking the region 1 as just before 4, not even equal to 4, and here just after 9, not even equal to 9, because if any of the interval touches this boundary like this, then they also need to be merged because they are overlapping with each other. And so we need to keep this condition in mind, that in region 1 we have to simply check for less than intervals. In region 3 it should be greater than the end time, and in this region if they overlap we have to directly merge them. So how we can solve this type of problem is, we have to take these 3 regions. First we have to take all the intervals which are part of region 1, and all the intervals which are part of region 1 will satisfy this condition, that their end time, let's say this part, is less than the new interval start time. It means they are not overlapping, there is a gap. So this less than condition is helpful. If they become equal, then they actually overlap and we have to merge them. So first we cater for less than condition and we figure out what are all the intervals which are not touching 4, 9. So those intervals we directly take into our result list because they are not touching 4, 9 and they are not overlapping 4, 9. So let's say if there are n number of intervals before 4, so we have to check each interval's end time and check whether it is less than the new interval start time. If it is less than the new interval start time, we know that they belong to this region. So after placing all the elements of region 1, we come to region 2. Now here what we check is, let's say if we take this example. So here if this interval has to belong in region 2, what we do is we take its start time and we check whether it is less than or equal to the new interval's end time. Now here we are checking for this condition, less than or equal to. So let's say phi is less than 9. So it means this interval belongs to region 2 because we have already excluded the region 1 intervals. And if any of the intervals is left, if this condition satisfies that phi is less than 9 or equal to 9, then this region, even if it expands beyond 4, 9, it will still overlap with 4, 9. And why we are taking this equal condition is because, let's say instead of 8, 10 we have 9, 12. So 9 is the start time, and if 9 is equal to new interval's end time, so still it is overlapping with this interval and we have to merge them. So it still belongs to region 2. So this is the main condition. For region 1, all the intervals end time should be less than new interval's start time. So they will completely belong into this area and they will be non-overlapping. In this region they will overlap. So we have to simply check the interval start time and we have to check it is less than equal to the new interval's end time. If that is the condition, they still overlap and we have to merge them. So here if you see 4, 9 overlaps 8, 10 because 8 is the start time and it lies before 9 because 8 is less than equal to 9. So therefore when we will insert this interval, it will affect 5,7 and 8,10, and we know the formula that how to merge the two intervals together, which we saw in our previous slide. So after we add all these elements into the list, whatever elements are remaining, these are out of the boundaries of this 4,9, which is the new interval which we want to insert. So we can directly add them into the list. They won't get affected by the insertion of this new interval. So after merging 5,7 with 4,9 and 8,10 with 4,9, it will become something like this. So our overall answer becomes 1,3, 4,10 and 11,12. So the algorithm is something like this. We have to skip and add intervals that come before the new interval to the result list. So all the intervals of region 1 which are coming just before the new interval, we have to simply add onto the list. We have to merge all the intervals that overlap with the new interval. So this interval and this interval, they are overlapping with this new interval. So we have to merge it with this new interval. We have to add that merged interval into the result. So this is the interval which gets merged. We add this into the result. And finally we insert the remaining intervals to the result. So these are the remaining intervals. There can be many intervals like this. We have to just insert them to the result because they are non-overlapping and mutually exclusive. So this region covers this part. This region covers the overlapping part, and this region covers all the remaining elements. So all these regions will be captured by a simple while loop in the algorithm. So let's move ahead and see the algorithm. So this is the algorithm. So this while loop is for the region 1 where we simply skip the elements which just come before the new interval. This while loop is covering the intervals which are getting overlapped with the new interval, and this while loop is just adding the remaining intervals. So let's see the demonstration of this algorithm step by step. We'll call the insert method. We'll pass the list of intervals and a new interval which we want to insert, which is 2,6. So let's say we have list of interval as 0,1, 3,5, 6,7, 9,10, and we need to insert 2,6. So if we plot all these intervals on the time axis, it would look something like this: 0,1, 3,5, 6,7, 9,10. We need to insert 2,6, which is from time 2 to 6. Moving ahead. So here we are just simply checking for the base cases, that if list is null or empty, we simply return the list. So currently list is not empty and it is not equal to null. So for the new interval, you can think that it's a valid interval. As we have to return the list of mutually exclusive intervals, we will create a result list which is currently empty. Now as we need to traverse each and every element of this intervals list, we'll create an integer I starting from 0 index. So first we are picking 0,1. Now in this while loop we are checking that whether 0,1, when this 2,6 will be inserted into the list of intervals, will this get affected or not. So first we check whether I is less than intervals.size. We are simply checking whether value of I is less than interval.size, which is 4. Because as we are traversing each interval one by one, there would be a time that I will completely traverse all the elements. So we need to break from the while loop at that moment. So currently I is less than intervals.size. The other condition we check is we get this interval. So we do intervals.get I. So we get 0,1. And as we discussed, we will check its end time with the new interval start time. And we check whether this interval's end time is less than new interval start time, because if it is less than new interval start time, it means they are not overlapping. There is a gap between. So intervals.get I is this interval. If we do dot end, we get 1. We check whether 1 is less than new intervals.start. So new interval.start is 2. So 1 is less than 2. So it means this condition comes out to be true. which signifies that 0, 1 doesn't overlaps with 2, 6. And we can simply skip this element and add it to the result list because this won't get affected by insertion of this new interval. So 0, becomes part of the result. Now we will increment I. I will come to the index 1. So I is less than intervals.size, which is 4. Intervals.get I, which is 1, which is 3, 5. Now we are at 3, 5. We check whether this interval's end is less than new intervals.start. So here this interval dot end, which is 5. We check whether it is less than new intervals.start, which is 2. So this condition comes out to be false, which suggests that all the intervals which were just coming before new interval have already been part of the result, and once we reach on this interval, this condition comes out to be false, which actually states that 3, 5 will either lie in the area of new interval or beyond that, but it won't lie here in the region 1 because this condition came out to be false. So ideally this while loop will terminate, which signifies that all the intervals which were coming before new interval have been added to the result list, and we can move ahead with the another while loop. I is less than intervals.size. Now here we actually check for the second region that whether 3, 5 is overlapping with 2, 6 or not. And we already discussed how we can do that is intervals.get I, which is this interval. We simply check its start time, which is 3. We check whether it is less than or equal to new intervals.end. So 3 is less than equal to new intervals.end, which is 6. So which is true. So it means these two intervals are overlapping, which is being proved by this condition. And so the condition in while loop comes out to be true. So first we will get this interval 3, 5. We assign it to current like this. Moving ahead. Now as we need to merge 2, 6 with 3, 5. So we know the formula that if we merge two intervals, let's say A and B, and let's say result interval is C, so it becomes C start becomes min of A dot start, B dot start, and C's end will become max of A dot end and B dot end. So here these two are the same conditions, and here C is our new interval only. We are simply merging 3, 5 into the new interval only. So new interval start will become the minimum of current start, which is this, and new interval start, which is 2. So minimum of 3, 2 will give 2. So new interval dot start will become 2, which is already 2. So this won't get changed. Now new interval end will become max of A dot end and B dot end. So current dot end and new interval dot end, we take max of it. So current dot end is 5 and new interval's end is 6. So if we take max of it, we get 6, which is assigned to new intervals dot end. So new interval's end doesn't get changed because it is already 6. So it means we have merged these two intervals and the resulting interval is same 2, 6. Because this new interval completely overlapped the current interval. Moving ahead. Now we are done with this interval also. So we'll increment I. I reaches to 6, 7. So here I is less than intervals.size. Now here if we do intervals.get I, we get 6, 7. So friends, here you can see that why this less than equal to is important. This 6, 7 is starting where this new interval is ending. So it means they are still overlapping because the interval start, which is 6, is actually equal to new interval's end, which is also 6. So therefore they are overlapping and we have to merge these two intervals as well. We can't exclude 6, 7 because it is just overlapping with 2, 6. So this condition is important. So the overall condition in while loop comes out to be true. We do intervals.getI. The interval 6,7 will be assigned to current like this. And we have to merge these two intervals now. So we'll use the same formula. The new interval.start will become the minimum of current.start, which is 6, and new interval.start, which is 2. So minimum will give 2. So new interval.start will become 2, which is already at 2. Now new interval's end will become the max of current.end and new interval.end. So max of current.end, which is 7, and new interval.end, which is 6. So it will give 7. So here is the one critical step, that new interval.end will become 7 now, because after merging these two elements, the new interval will expand to 7 like this, that we have merged these two intervals. Moving ahead, we will increment I. I becomes 9, 10. I is still less than intervals.size, because value of I is, this is 0, 1, 2, 3. 3 is less than 4. Intervals.getI, which is 3, will give 9, 10. And here you can see this 9, 10 is actually belonging to the third region. So therefore its start, if we compare it with new intervals.end, so 9 is less than equal to new intervals.end, which is 7. So this condition comes out to be false. It means 9, 10 is the remaining element and it doesn't overlaps with 2, 7. So we can directly add this 9, 10 and all the elements after that via this while loop. So this condition comes out to be false. So here you can see that before adding 9, 10 into the result list, we have to also insert 2, 7, which is our merged interval, into the result, which is actually merging 2, 6, which was our new interval, with 3, 5 and 6, 7. So after this 3 intervals merge, we get 2, 7. So this is one important step. We have to add this new interval into the result. So it will become like this. And now using this while loop, we will add the remaining interval into the result. So I is still less than intervals.size. And as this condition reached this while loop, we are sure that all the remaining elements will be non-overlapping with this new interval. So we can directly add 9, 10 to the result. We do result.add and we pass in intervals.getI, which is 9, 10. So it looks something like this. And then we increment I. So I goes beyond the boundaries of this interval list. And now this while loop condition comes out to be false, because value of I is 4 and interval.size is also 4. 4 is not less than 4. So this condition comes out to be false. And at the end we simply return the result, which is 0, 1, 2, 7 and 9, 10. 0, 1 doesn't overlap with this new interval and 9, 10 also doesn't overlap with this new interval. 3, 5 and 6, 7 were merged with 2, 6 and became 2, 7. So this was the answer. So friend, this was all about the algorithm. I hope you must have liked this video. In case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Thanks, have a nice day.